So basically you just do a double integral for a plane and then integrate that over another dimension.
Yes, you can think of it this way. So basically there are, you can even formalize what you just said. The way to see it is, as we chose the order JIK, that means it makes sense to change the order of multiplication here. It makes sense to multiply it by delta y first, because then you would recognize the innermost sum as an integral with respect to y of a function of two variables. No, of one variable y, but two constants, x and z. And then, if you keep staring at this formula, what you can recognize is that after you do this integral with respect to y, what remains here is a function of two variables, x and z, because y is going to be gone after integration. And that function of two variables is going to be integrated. And what you will do with that function of two variables is exactly the double integral. So all that happens here is that you're doing now a double integral like this, where the integrand itself is an integral with respect to the third variable. So that's how you insert third dimension. And again, of course, you should expect the limits to be functions, not only the integrands. So we'll come to that later. But in this simple case, the limits will be constants. So let's finish this case first. So how do we proceed? So we recognize this together with that condition of taking limit as an integral. And we are left with the limit as delta x goes to 0 and delta z goes to 0 of sums over k of sums over I of integrals with respect to y of the function f of xi, y, and zk, and that integral has to be multiplied by delta x and delta z. And then we ask what the limits should be for the variable y. And 0 and 4, yes. And you see, the simplicity of this example is that no matter which string of elements, which stack of y, well, in y direction you choose, it will always go from y equals 0 to y equals 4. And that's the simplicity brought to you by the box shape. So you have 0 and 4. And then once you finished with that integral, you look at the next summation with respect to x. That looks like an integral after you pass to the limit. So you have the limit as delta z goes to 0 of sums of integrals with respect to x of what? Of integrals with respect to y. And, well, yeah, the variable x shows only in the integrand in this case, so change it. You drop the index I, integrate from 0 to 4 with respect to y, and with respect to x, you integrate from -3 to 0. And then the whole thing should be multiplied by delta z. And now if you look at that iterated integral. since dy and dx will make x and y disappear, the whole thing is a function of z, k only. And the whole thing looks like an integral with respect to z, so it is an integral with respect to z. And that z changes from 0 to 2. And what you integrate is an integral from -3 to 0 with respect to x of integrals from 0 to 4 with respect to y of the function f of x, y, z. And the last thing is to figure out what the function is, f of x, y, z. So it's supposed to be the distance to the origin squared. If you take a point x, y, z, the distance to the origin is square root of x squared plus y squared plus z squared. And square of that square root is exactly the sum of squares. And the rest is iterated integration. Just do the partial integration with respect to y, keeping in mind that y is going to be a variable, x is constant, z is constant. Then substitute the values for y, integrate with respect to x, then with respect to z.
Would you suggest a good strategy then when doing that is to write out the function the same way we're going to do the iterated integral? So do y squared plus x squared plus z squared.
It doesn't matter. And the way you write down the function doesn't really matter.
I just meant like as a strategy to reduce the amount of error.
Well, if you believe it may reduce, you will use that. I just never thought about it myself. So. So what we basically did is we converted the triple integral into iterated, and of course it has to be iterated 3 times because we are dealing with 3-dimensional integration. Well, the rest I think we can skip for now. So speaking of the choice of the order, sometimes for either computational reasons or for the reasons of better understanding, when you, well, in this setup you don't distinguish x, y, and z variables. I mean, for us, direction of x and direction of y, direction of z, they're roughly the same. So in some cases you may be interested much more in direction of y rather than all the others. And then you may prefer to integrate with respect to y first or with respect to y last. So this choice of the order of iterated integration may be influenced by some external reasons which are outside of calculus. For the reason of computation, if you get a function, then this function, well, it doesn't matter which variable to integrate first, right? If you had a function like that, it's probably easier to integrate with respect to, what do you think? Z, right? Because with respect to z, that's a constant. So if you look at a function and you choose the coordinate system and you see that the formula is sort of special, for example, it doesn't have z variable, you may want to choose the order so that z becomes first. But again, this is rather technical aspect that I don't want you to even look at for now. I'm just saying that this choice of the order is usually not totally random. And this is almost the last integral for the whole semester.